Sixth grade, happy Friday. Welcome to lesson 63 in math. Hopefully you're done with the quiz on the back side. Work those problems. I'll rattle off the answers on the front side. You know how this works. Circle any ones you and I might possibly disagree on as we get cranking through this thing. 1/2 is 0.5 and 50%. 1/3 is 0.3 repeating and 33 and 1/3%. 2/3 is 0.6 repeating and 66 and 2/3%. 1/4, 0.25, 25%. 3/4, 0.75 and 75%. 1/5, 0.15 and 15%. 1/8, 0.125, 12.5%. 1/10, 0.1, 10%. 3/10, 0.3, 30%. 9/10, 0.9, 90%. 1/100 is 0.01 and 1%. 1.5 is 1.5, 150%. Mental math one like this, letter A, you took 246 times 5, got 1,230. B, slid it left 3 times, got 0.004. C, you had to, I cross multiplied because it didn't go evenly. You could have reduced 15/20 to 3/4, then you would have taken it times 2 and got 6. Cross multiplication, 120 divided by 20 is 6. D, liters to milliliters, right 3 times gives you 500. The square root of 196 is 14 for E. F, divide by 8 gives you 3 times 3 gives you $9. G, what type of triangle has 2 equal sides? That's an isosceles triangle. That's the work from the other day. H, instead of multiplying 50 by 28, double 50 to 100 and cut 28 in half. So that's 114. 100 times 14 is 1,400. Problem solving. Jamila has 2 standard number cubes. If she rolls the cubes together once, what totals does she have a 5/36 chance of rolling? Guys, I just went to my yellow folder. Way in the back, we know we can look there to find all the possibilities of rolling a dice, and then I looked which one has a number up here 5 times. There's actually 2 of them. I can get a 6 and I can get an 8. That will happen 5/36 of the time. Okay, so I just used my yellow folder. It didn't take any math on my part to do that. All right, guys, we're about to cruise on. We've been working with classifying triangles, working with quadrilaterals on Tuesday, working with area of these things on Wednesday, and today we got order of operations to the next level, which is called symbols of inclusion. So I'll just read it to you. It says, parentheses are called symbols of inclusion. We have used parentheses to show which operation to perform first. For example, to simplify the following expression, we add 7 and 5 before subtracting their sum from 15. Brackets that look like that and braces that look like that are also symbols of inclusion. When an expression contains multiple symbols of inclusion, we simplify with the inside the innermost first. So to simplify this expression that they gave you, 20 minus 15 minus 5 plus 7, you would start by doing this guy first because it's innermost. So that's how they got the 12. Then you move to the brackets next. That's how they got the 3. Then you do the final one, and it finishes off. So we're going to work from inside the parentheses, outside, innermost, outward, to be able to do those things. Turning the page, we get to work on example number 1. It says, simplify this problem. So guys, the first thing I do is my innermost one, which is that. That gives me a 5. Then I do 20 plus that 5, which gives me 25. And then I do 50 minus 25, which gives you your final answer of 25. Okay? So they're just giving it to you step by step, guys. I like how they do that. Then they said you can do the same thing trying to go horizontal, where they just rewrite it and then, you know, put the answer in and then put the answer and get the answer. I personally like up and down like this. So you do what works best for your brain. This is too much for me side to side. I don't like that. I like up and down. Okay, so example 2 says, let's simplify it again. What they're encouraging you to do, guys, is to say, I'm going to do 12 minus 8 minus, this is the first thing to do. The absolute value of that would be 2, because it would be -2, and absolute changes it back to +2. Then I would have this in parentheses that looks like that. So I have 8 minus 2 is 6, plus 2 is back to 8. That's how they got the 12 minus 8. And then the last thing down here, 12 minus 8 is 4. We got a little something to read there. I'm going to erase where I wrote so I can read that for you. It says, as we noted in lesson 52, a division bar can also serve as a symbol of inclusion. We simplify above and we simplify below the division bar before we actually do the division. So we follow order of operations within the symbols of inclusion. So up here, guys, I'm going above. I have 4 plus 5 times 6 minus 7. So I would multiply first, get 30. Then I have 4 plus 30 is 34, minus 7 is 27. On the bottom, parentheses first is 1, 10 minus 1 is 9. Finally, the division, and you get the 3 down there. Okay, now guys, 96% of the time, it's going to come out to a whole number. If it doesn't come out to a whole number when we're doing symbols of inclusion, you might have done order of operation wrong. So there is a few rare occasions, guys, where it's not like that. But in general, I would recheck my work if it didn't come out evenly. And then if you recheck it and the answer is still 3.5, great. Then you found the exception where you had a decimal answer. But normally it's going to come out evenly. Okay. Then they say, hey, guys, a lot of times you like to use calculators to do those things. Some calculators with parentheses keys are capable of dealing with many levels of parentheses, parentheses within parentheses within parentheses, when performing calculations such as the one in example 1. We press the open parenthesis key for each opening parenthesis, bracket, or brace. We press the close parenthesis key for each closing one. For example, problem 1, they give you all these parentheses you have to press to be able to do that thing. Okay, guys, you do what you want. There are calculators that do that. So I have a picture of a calculator that understands order of operation. Now, guys, you see all these buttons here. If your calculator has a lot of buttons, it does order of operation. If your calculator does not have these buttons and it only has this down here, some cheap calculators have a few, like it'll say M plus and M minus buttons. Those don't do order of operations. Now, I typed one in for you guys so you can check it. If I was just using a calculator that's a cheapo, as soon as I press 3 times 3, if I hit the plus button after I did 6 times 3, it'll instantly say 18. Then I would hit plus 3. It'd instantly add that 3 to it automatically. This, you can see, did what it was supposed to. It did 6 times 3 is 18. It did 6 times 3 again, which is 18, and then it went back and added together to 36. So my calculator understands scientific notation. In general, if you have a lot of buttons, it understands scientific notation. Okay? Now this calculator can do what they were just talking about, guys. Here are your parentheses buttons. So I could type in there and put things in parentheses if I do it. Now your book might use parentheses. They might use that bracket. They might use that brace. You can use parentheses for all of them. It doesn't matter. I can have a parenthesis and a parenthesis and a parenthesis, all like that, separating things out. You'll see that as we work through that. Your book sometimes gives you bracket and braces just to help you because they think this scares 6th graders to have parentheses stacked on top of each other. It's no big deal. All right, guys, this is order of operations to the next level, and we have been starting to get ready for signed numbers in there. We're going to do that more and more, too, start printing positive and negative numbers as we continue to practice that. Okay? You want to work with you on the practice set? Awesome. If not, you have that set aside, your power-up set aside. We're ready to start working some problems, guys. Your yellow folder, if you were looking at that, did not have any blanks to be needed to be filled in. So we don't have any of those things. I'm going to get cranking. Here we go, number 1. Jennifer and Jason each earned $11 per hour doing yard work. On one job, Jennifer worked 3, Jason worked 2.5. Altogether, how much did they make? So step 1, Step 1, 11 times 3 is 33. Step 2, 11 times, I'm going to switch it to a decimal, 2.5. And I'm going to switch that the other way around and do 2.5 to 11 because then that's just 2.5 and 2.5. Okay, so it's 5, 7, 2, 1 decimal point, 1 decimal point. Now I got to go back and add them together. So 0 if I want it, 0 plus 5 is 5, 3 plus 7 is 10, 1, 3, 2 is 6, decimal points. Okay, 6, it's money, so I'm going to add a 0 here and a dollar sign. So $60.50. Number 2, when Marisol was resting, her heart beats 70 times per minute. When she's jogging, it's 150 per minute. During a half hour of jogging, Marisol's heart beats how many more times than if it were resting? Okay, so I'm doing 30 minutes, guys. So I got, if she's resting, I have 70 times 30. Well, 7 times 3 is 21. Slap on those 2 zeros. If she's jogging, she's doing 150 times 30. So I do 15 times 3, and I get 45, and slap on those 2 zeros. Now, they said, what's the difference between those two? So I have to subtract them. 5 minus 1 is 4. 4 minus 2 is 2. It's a difference. Her heart's going to beat 2,400 more times if she's running than if she's resting. Good exercise. Lowers your heartbeat eventually when you're done. Number 3, use a ratio box to solve this problem. The ratio of pairs of dress shoes to running shoes. I have a pair of dress shoes to running shoes. My ratio to actual. At Shoe Fly store last Saturday was 2 to 9. 720 pairs of running shoes were sold. How many dress shoes were sold? The 720 goes down here. That is times 80. So I take 6 times 2 and I get, I take 8 times 2 and get 16, and now add that 0. It's 120, it's 160, my goodness, sorry, I can't talk. 160 pairs of shoes. Number 4, during the first 5 days, a hiker on the Appalachian Trail averaged 17 miles a day. During the next 2, they traveled 13 and 19. The trail's a little more than that many miles long. About how much farther does it have to travel? A long way. So step 1, average 17 times number of days they did it. That's 35, carry the 3, 5 plus 3 is 8. So in the first 5 days, they went 85. Then I have to add the 13 and the 19. 8, 17, carry the 1, 9, 10, 11. I'm at 117. The whole trail is 2,174. I've traveled 117. I'm going to subtract 6. Boom. 14 minus 7 is 7. 6 minus 1 is 5. 1 minus 1 is 0. 2 minus nothing is 2. I have about 2,057 miles still to go. That's a lot. A lot more days. Continuing on. Number 5. Yesterday, the hiker began at 2,850 feet above sea level, climbed over a 5,575-foot high summit, descended 2,695 feet before stopping at the night. What was the hiker's net gain, loss, and elevation during the day? How did you find your answer? Okay, guys, so here's my mountain. I'm starting right here at 2,850, and I'm climbing up here to the peak, which is 5,575. So I got to figure out how far I climbed by subtracting. 575 minus 2850. 5, 2, can't. 15 minus 8 is 7, 2. So I climbed up 2,725 feet. Now it says, now we started to climb back down 2,695 feet. So I'm going to subtract that from my answer. I got a 5, can't, 6, 12, 3. Done and canceled. So it says, the question was, what was the hiker's net gain or loss in elevation? It was a positive 30. So guys, if this went straight across, this is where they are. He actually stopped right here, 30 feet higher than that. So they gained 30 feet. I leave it positive. The second question was, how did you get your answer? I subtracted twice. Okay, this is how I got my answer. So guys, this is why we show our work. When we show our work, it's obvious how you got an answer. I can see your work. But if you want to write it, you subtract twice. Number 6, the average distance from the Earth to the Sun is that number. Use words to write that distance. Okay, so the first thing I'm going to do, guys, is I'm going to write it out in number form. So I have to slide that thing 8 times to the right. So that's once to the right, twice to the right, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times. Go back in, 1, 2, 3, 1, 2, 3. Awesome. Now I'm going to write that in words. That's 149. Don't forget your hyphen. And that is 149 million, comma, words, 600,000. And we are talking about kilometers. Some of you might know that that is 93 million miles. So you might as well get some extra credit for knowing that. At the top of your page, write down, what number am I on? 6. Right at the top, 6 equals 93 million miles. Oh, extra credit at the top of your page, you put that thing down. Now you know the average distance we are from the sun. Number 7, read the statement and answer the questions that follow. 12 of the 40 cars pulled by a locomotive were tankers. What fraction of the cars were tankers? Okay, well, the answer is whatever they just told me, 12 of the 40. Now, guys, obviously can't leave it like that. I need to divide by 4. That gives me 3/10. B says, what percent of the cars were not takers? Well, the opposite of 3/10, guys, is 7/10, which equals 70 over 100, which equals 70%. Number 8, to convert inches to meters, we multiply the number of inches by 2.54 times 10 to the negative second. Use this fact to convert yards to meters. Okay, so I know that a yard equals 36 inches, guys. So what I'm really doing is I'm taking 36 times 2.54 and then times 10 to the negative second. I'm going to do this at the end. So first I got to do my multiplication. 6 times 4 is 24, carry the 2. 30 plus 2 is 32, carry the 3. 6 times 2, 12 plus 3 is 15, add a 0. 3 times 4 is 12, carry the 1. 15 plus 1 is 16, carry the 1, 6, 7. Add 4, 4, 11, 9. Now I have 1, 2 decimal places from here, so 1, 2 here. This says slide left 2 more, so 1, 2 again, and I'm all the way to there. So it equals 0.9144 meters. That was a sweet problem. Number 9, use a unit multiplier to convert kilometers to meters. Guys, that's times 1,000, so 1.5 times 1,000 is right 3 times. So once, twice, 3 times. I have 1,500 meters. Number 10, divide that by that and write your answer with a bar over the repeatant. So we have inside the box, 4.36. Outside the box, 0.012. 1, 2, 3, 1, 2. Add a 0. Decimal points here, it's going to go straight up. So 12 goes into 43 3 times. That's a 36. Can't do the subtraction. 7. Bring down the 6. 12 goes into 76. 6 times. That's 72. Get a 4. Bring it down. Goes in there 3. That's 36. Get a 4. Bring a new 0 down. Goes in there 3 times. That's a 36. Get a 4. And now I have it, guys. Remember, we have repeating decimals. So let me erase that. My answer is 363.3. Repeating. You can't put the repeating bar over this, guys, even though that's where it starts, because it's not past the decimal point yet. Number 11, show the addition problem on the number line. So I have -3 plus 5 plus -2, and then they just put it all in parentheses so that we don't confuse things. Guys, I'm going to start here left to right. Signs are different. I subtract. 5 minus 3 is 2. Signs are different. I subtract. 2 minus 2 is 0. Number 12, complete the table. They gave me 33%. Left twice is 0.33. There's no bar, guys. It's not 33 1/3. Said correctly, that's 33 hundredths. 33 hundredths. And I remember my teacher telling me if it ends in 1, 3, 7, or 9, it can't be reduced. Done. Next one, they gave me 1/3. That's slightly different. You know that is 0.3. Repeating, which is 33 1/3%. So they're just testing you to make sure you don't put the same on the top and the bottom, guys. It's slightly different. Number 13, describe the rule of the function, then write the rule as an equation using x and input for y. Begin by writing y equals. So they keep practicing this, guys. They gave me 3, it equals 1. They gave me 12, it equals 4. They gave me 6, it equals 2. I am doing what? I am dividing by 3. Okay, now, can I write that as an equation? You bet. Y equals whatever x is divided by 3. Done. Some of you know that dividing by 3 is the same thing as multiplying by 1/3. A lot of math books would write it like this. Y equals 1/3 x. It doesn't matter. They're both the same. Do whatever one makes more sense to you. You wrote divide by 3, so that one would be how you would write that as an equation. Number 14, a deck of 26 cards has one letter of the alphabet on each card. What is the probability of drawing one of the letters in the word math from the deck? Well, guys, there's 26 letters, and you got 4 letters to choose from. So it's 4/26. I'm going to divide by 2/2, which equals 2/13. Number 15. In the figure below, AB is the same as AD, which is the same as BD, which is the same as CD, which is all 5 centimeters. The measure of angle ABC is 90 degrees. Refer to the figure to answer 15 through 17. So I'm going to draw this thing over here. And I did not do a very good job drawing that, but this is 5 because AB is the same as AB, which is the same as which is the same as A. Classify the triangles based on sides. Okay, I did labeling wrong. Hang on. AB, which equals AD, which equals BD. This guy is, oops, back to my pen. This is 5, which is the same as CD. This is 5. This guy on the bottom is not 5. So I'm looking at BCD. This is the same as this, guys. So for 15A, that's isosceles. We have 2 sides the same length. B, what is the perimeter of the equilateral triangle? Well, guys, they gave me 5, so 5 plus 5 plus 5 is 15 centimeters. Which triangle is a right triangle? The big one. This to this to this. So up here, A to B to C. So triangle A, B, C. Number 16, it says, can you find the measure of each of the following angles? So I'm going to draw this again so I can start putting in these angles for you. We know this triangle here, guys, is an equilateral triangle, which says they all the same measurement. So 60, 60, and 60. We know this guy added up to down here in the corner was a 90, so 60 plus 30 equals 90. We know this forms a straight line right here, so 60 plus 120 gives me my 180. And then I add these together, 120 plus 30 is 150. Subtract from 180 is 30. Okay, here I go with 16, answering the questions. BAC is this guy, 60 degrees. I'll write a little A there. B, I'm to ADB, ADB, that guy, 60 degrees. C, BDC, BDC, that guy, 120 degrees. D, DA, DBA, D down to B to A, that guy, back to 60 degrees. Ooh, what did I just do? Sorry. E, D to B to C, that guy, 30 degrees. And last but not least, D to C to B, this guy, 30 degrees. Okay, so you need to know equilateral gives you all 60s because of the right triangle. This one had to be 30 to equal 90. And then straight line, 180, triangles, 180. That's how we got those last two. 17 says, what is the ratio of the length of the shortest side of A, B, C to the longest side? Well, the shortest side is right here, guys. That's 5. So I'm going to put 17 in here. The longest side is out here. That's 5 plus 5 is 10, so it's 5/10. That reduces to the ratio of 1/2. So, okay, 16, 15, 16, and 17. Obviously, halfway through that problem, you had to flip your answer key over as we were cruising along doing those problems. We're up to number 18. 18 says 5/18 equals x plus 1/12. Missing something addition, I subtract. So I have 5/18 minus 1/12. Common denominators are 36, guys. That's going to take this one times 2, which is going to give me 10/36. This one's going to be times 3. Give me 3/36. Subtracts gives me 7/36. Number 19. Missing a letter next to a number means multiply. To solve it, I divide. 2's in the box. 0.4 is outside the box. Add a decimal point, add a 0, because I have to slide it over once. So I have to slide it over once. 4 goes into 20 5 times. 20. Woo! Welcome to today's problem. 3/24 minus 8 plus 3 times 2, and that's in parentheses. So I drew it with parentheses, guys. This was really a bracket, same thing. Then I have a minus, and I have to do 6 plus 4 divided by the absolute value of -2. Okay, so innermost first, guys. So I'm starting with this, and then this is multiplication here. So I start there. 3 times 2 is 6, plus 8 is 14, minus 24. So I'm done with the first set of parentheses, guys. Now I got this next set of parentheses, and I have a 3 next to it. So now I have 24 minus 14 is 10. Parentheses next to that means multiply. I'm at 30. I do all that minus, now here, 6 plus 4 is 10. The absolute value of -2 is +2. 10 divided by 2 is 5, so I'm subtracting 5 at the end. And 30 minus 5 is 25. We're going to get at least one of these a day, guys. They're awesome like that. Training your brain to do those things in the correct order that you're doing it. Number 21, 3 cubed. 3 times 3 is 9, times 3 again is 27, minus the square root. 3 squared is 9, 4 squared is 16. Add those together is 25. Square root of 25 is 5. 27 minus 5 is 22. Okay? Now, be careful, guys. Some of you might have been tempted to do the square root of 3 and the square root of 4 and say square roots cancel squares, so I can just cross that all out and add that together and get 7. That's only when you're multiplying, not when you're adding. So don't get trapped by that one. Number 22, 1 week, 2 days, 7 hours, minus 5 days, 9 hours. Okay, step 1, can't do the day. I can't do the hours. Cross out the day. Bringing over 24. Adding it to the 7 is 31. 31 minus 9 is 22. Can't do that. 7 days in a week. Add to 7 gives me 8. 8 minus 5 is 3. My answer is 3 days and 22 hours. 23. I have 20 miles in 1 gallon, and I have 1 gallon in 4 quarts. Gallons are gone. 4 goes into 20 5 times, so I'm doing 5 miles per 1 quart. So we're simplifying and creating a label. Many times we'd write that not with that 1 there. We just say 5, and then my label would be miles per quart. Okay. We never talk like that. We always say, how many miles to the gallon do you get? Well, I got to get 20 miles to the gallon. Okay, well, what is that per quart? Well, you don't buy gas per quart, guys, but that's how you convert it. 24. We have 4 2/3 plus 3 5/6 plus 2 5/9. So 3 numbers, I got to find the common denominators of them. It's 18. Got to multiply by 6 over 6. 2 times 6 is 12. Got to multiply by 3 over 3 is 15. Got to multiply by 2 over 2 is 10. I'm going to bring my whole numbers across so I don't forget them. I'm going to add 12 plus 15 is 27, plus 10 is 37. 37/18. I'm going to divide. 18 goes into 37. 2 times. That's a 36. Subtract gives me 1, so I'm left with 1/18. 2 plus 4 is 6, 9, 10, 11. It's 11 and 1/18. Make sure you're getting your work shown with that. 25, 3 fractions. This time they are going to be multiplied. So I have 12 and a half, 4 and 4/5, and 3 and 1/3. Multiply. 24 plus 1 is 25 over 2. 24 over 5. Multiply. I wrote 1/2. It should be 1/3. 9, 10 over 3. Now I'm going to cancel. 2 times 5 is 10. 3 goes into 24 8 times. And I'm left with 25 times 8 on the top. That's 40. 16 plus 4 is 20. My answer is 200. 26. I have 1 2/3 divided by 3. 3, 4, 5/3. Stay, change, flip to 1/3. Multiply the tops, 5, multiply the bottoms, 9. Now I'm going to take that, I'm going to do 6 1/3 minus this 5/9. This is times 3 over 3 is 6 3/9. Still can't do the subtraction. Cross out the 6, make it a 5. Add 9 to my 3 is 12. 12 minus 5 is 7. 9 stay the same. 5 minus nothing is 5. I have 5 7/9. 27 says, please evaluate x squared plus 2xy plus y squared if x is 3. So I'm going to go 3 squared. Sorry, I'm going to stick the number in right now while I do it. I'm going to do, look at what I did. I did the square up here. I'm going to do 3 squared plus 2 times 3 times 4 times plus, not times, plus 4 squared. Now the math, exponents first. That's 9, that's 16. Then the multiplication in the middle. 2 times 3 is 6, times 4 is 24. Now addition left to right. Now it's all addition, guys, so I can go any order. If you want to do it this way, because that adds up to 40, and then 9, you get 49. Normally it's left to right, but because it's addition, guys, you have the commutative property kicking in. The only time we have to go left to right is if it's addition and subtraction. There's no commutative property of subtraction. If it's all addition, you can go either direction. Any way you look at it, guys, the answer, 49. Turn to my math book for the final 3. 28 says, draw an isosceles triangle that is not equilateral. All right, that's obvious that it's not equilateral. If I want to draw an isosceles triangle, guys, I put marks there. That little mark says the right side is the same as the left side. And so you're telling the teacher, I want to draw an isosceles triangle. Lots of times students just go like this and call it a day. Now, does it look like an isosceles triangle? Yes, it does. But when they tell you to do it, put your little marks in here to say it is an isosceles triangle. Okay, how do I chop it? I chop it with a line of symmetry vertically. 29. Della and Ray are planning to build a patio in the shape of a parallelogram. They sketch the patio on graph paper. Each square on the grid represents 5-foot square. The corners for vertices are ding, 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 ding. All right, let's see if I can get a new screen. Here we go. Point number 1 is 0, 0. Point number 2 is 1, 2, 3, 4, 0. Next point is at 1, -3, over 1, down 3. Last one is at -3, -1, 2, 3, down 3. So I went from here to here to here to there. Okay, that was A. I sketched it. Now B says, what is the area they are planning? So guys, I need to figure out the height, which is 1, 2, 3. I need to figure out the length, which is 1, 2, 3, 4. I need to take 3 times 4 and get 12. And I might get that wrong if I stop right there. Okay, because what did they say? The grid represents, each square on the grid represents 5-foot square. So now I might say, well, I gotta take this times 5. I would still get it wrong, guys, because this is not a length of 4. This is a length of 4 times 5. Just like it's not a height of 3, it's a height of 3 times 5. So it's not times 5, guys. It's times 5 squared. So I got to take this times 25. Okay, that's a 10. Carry the 1. That's a 5. That's a 6. Add a 0. 4, 2. Add it. 0, 10, 1, 3. It's 300 feet squared. That was a tricky problem. Many of us might have said it's 12. Some of us might have said it's 60 because we took 12 times 5. That was great math there. Number 30. 3 identical boxes are balanced on one side of the scale and 750 grams on the other side. What's the math? Okay, guys, 3 boxes looks like this. 3 boxes equal 750. Divide by 3, divide by 3. Cancel. Gives me B. Divided gives me 3 goes into 7 twice. That's a 6. It's a 1. 3 goes in there. 5, 0. It is 250 grams. We are going to start to get these algebra problems all the time. All right, 6, we got all 30 problems done.